Starting with project 1, the topic is Mini Bach Harmonizer, Let Bach Back You Up. A simple web application inspired by Google's first AI-based doodle, the Mini Bach Harmonizer is a tool for musicians and music enthusiasts alike. The team members are Ajinkya, Bhaskar, Shibani, and Shrish. Over to you guys.
Thank you, Bhavna, for providing us this opportunity. Shibani will share a screen now.
Hello, everyone. Just starting to share screen now. Okay, good evening, everyone. Welcome to the Mini Bach Harmonizer. This is our final project for MLOps for Univ.AI. Let's get into what we did, the how, the who, and the why, all of it. Let's start. Well, what is our project? Wouldn't you like Johann Sebastian Bach to jam with you? Well, we would, and that's how we came up with this idea. Before we go any further, what's a melody and what's harmonies? Well, let's start with something simple. That would be our input. What's simpler than this? Sounds familiar. Well, how does that sound with harmonies? Well, as you saw, it makes a world of a difference. It's not just the melody, but also the accompaniments that bring the music alive. As mentioned, the Google's first AI-powered doodle from 2019 is our inspiration, and it's been collecting user data all this while with due consent, of course. Let's get into the how. Well, if both the doodle and our project use CocoNet as the base model, which is the machine learning model we've recreated, what's the unique thing? What's different? Well, the first thing is we're only working with the outputs of the doodle that was originally trained on complex symphonies composed by Bach himself. The second challenge that we made ourselves face quite intentionally was we went ahead and chose only about 1% of the data to work with. We saw a lot of repetition, then we wondered, well, could we use only a fraction of the data and recreate the Bach magic?
Yeah, so let me walk you through our model now. So the basic unit of our model is a fairly straightforward convolutional neural network with batch normalization and residual connections. And we repeat these basic units a number of times, followed by a dense layer at the end. For training, we treated the music for each voice as represented in piano roll, which is nothing but a two-dimensional array with discretized time and pitches. And we stacked these different voices as a convolutional feature map, wherein these voices it's different channels for these convolutional feature maps. Next, we added one additional channel per voice called mask, which indicates whether the pitch for that voice is known or unknown at that point in time. The resultant 8-channel feature map is then passed to our model, which produces the prediction probability distributions across different pitches over different times for different voices. Initially, we sampled all of the pitches simultaneously, which results in a complete but typically nonsensical score. So we erased some of them and then again passed it through our model, and the whole process repeats again. Through this animation, we can see that over time, we erase and rewrite fewer and fewer notes, enabling the process to settle on a coherent result. Now, let me give you an overview of our technical stack. So while building this app, we got to wear many hats, be it of developer, ML engineer, or ops, and we appreciated how everything comes together in building the final product. So we use TensorFlow for developing our deep learning models and Google Colab for training the models. Docker containers were used to segregate our development environments, and GitHub was used as our source control. Now moving on to the ops side of things, we used fast API to provide REST interface to our backend and Node.js and JavaScript as our frontend. Final model was deployed on Google Kubernetes Engine, and Nginx server was used as our forward and reverse proxy between the outside world and our frontend. So that was the MLOps for you.
Well, let's move into the who this application really helps or what the applications are. Beyond entertainment, which is a fun interactive tool for everyone, it can also have a two-tier scale. For novice users, they can use open source music, relying on classical music like that of Bach to generate and inspire their own harmonies. For advanced users, we could also eventually have an ability to let them upload their own data and let the AI approximate their particular style. For future scope for us includes two things. Well, we aim to collect user feedback for each run. That's because art is subjective and we'd love to hear what our users say. And secondly, we'd love to extend this input and harmonies to a longer phase, moving into the generative phase, experimenting with generative models perhaps. Well, hearing is believing. So without further ado, let's go to our demo. Here we are. I hope you can see my screen. So this is our web app. As you can see, we have a welcome page with a few simple instructions. All you do is use the cursor to fill in your melody, whether it's soprano, alto, tenor, or bass. Pick your favorite and let the app do the rest. What's more, we have a bonus feature now. If you don't like the sound of our output, you can erase the sections that you don't quite prefer and hit harmonize again and wait for the model to give you yet another result. Well, let's get started. Okay, this is our interface. Don't get confused by the million boxes. It's basically a representation of a piano. So perhaps over here you have the middle C, and think of these as piano keys moving through time. To give you a certain insight, we give a sample melody right here. Let's hear that. That's simple enough. What happens if I hit harmonize? Bach is getting busy. Well, as you see, the interface is simple enough for a novice user to click around and make a fun melody. It's also intricate enough for somebody who knows a little bit more about music to get a bit granular and change the notes around, change the voice, erase, redo. The solution. The harmony is ready. Let's hear it. Well, that wasn't bad, was it? There's also more features here. You can change the scale you're working with if you're familiar. There's also a save button. I can hit save. Well, yeah, I do trust this website. We can save that MIDI file, and MIDI files are rather robust. They can be converted into any media format. You can change them later on. In fact, just yesterday, we used our model to wish one of our friends happy birthday. I think we have that here. Let's hear that too. Well, there's some room for improvement, but I think that sounded pretty good. Thank you, everyone.
Thank you, Shivani. That was wonderful. Really nice. That bird happy birthday, a little bit jazzy for me, but that's okay. That's the way to go. Do we have one question? We have time for one or two questions. Yes.
Hi guys. So I wanted to ask, how are we incorporating the scales and the modes? Suppose I want like Bach in Mixolydian or Aeolian. How are we going to incorporate that?
Well, Rish, the model is up to training with you give it. And as a user, if you put in whatever input, it's up to you, right? If you want to limit yourself to the scale that you are referring to, if you want to work with pentatonic notes or minor notes, that's up to you. So if you we'll share the link rather. So if you look at the interface, you can change the scales, you can work in any scale you want. You're only limited by the keys, which makes it in fact easier for you to stick to the key of your song so that you don't accidentally click notes that don't sound good together. But for scales, it's up to you what input you provide.
Okay, since nobody's asking, I will ask. First of all, is the URL available to all of us?
Yes, yes, it is.
Yes,
Happy,
Professor,
please
I'm
put that
just
in chat.
sharing it. Yes, yes.
Okay. Second is, can this scale? So if you all of a sudden, this becomes the most popular new app after, I don't know, Chat GPT, can this scale up?
Yeah, to answer that, Professor, yes, we have deployed it on a Kubernetes cluster. So for now, we have just 2 virtual machines just to take care of the failover part. But going ahead, if we anticipate that, yes, we are going to have more traffic, then we can scale it to more machines.
Okay. And where is it hosted, on GCP or AWS?
On GCP, yes, on Google Kubernetes cluster.
Have you thought about putting this in some kind of a serverless thing? Because, okay, maybe you won't become so popular. Maybe we don't need to have the whole Kubernetes cluster, or we haven't thought about that.
Right now, we haven't thought on that aspect yet. But going ahead, we can see and just pivot accordingly.
A wonderful presentation, I must say.
And Professor, just to add one more thing. So initially you mentioned that the happy birthday was a little jazzy for you. So
yeah,
now we have incorporated one more functionality in our front end that you can erase some of the parts which you don't like and then reharmonize again, and it will give you another harmony.
Okay, great.
So you can
So
try that out.
So in India, when you have happy birthday, what do you sing? The happy birthday to you, or there's a different song?
Yeah, generally we say, yeah, happy birthday to you. And
the Indian version of the original Happy Birthday song.
It goes faster, right?
I think there's another question from Bridge.
All right, Bridge, go ahead.
My question is, like Happy Birthday is got simple song, simple tune. You know, in Indian classical music, it is more based on melody. So have you tried any of ragas into this? So like some ragas don't have fixed scale as well. Which is you can't find the tune, the swara into the keyboard and all, because it is somewhere in shrutis. The line, the sound, some sound in the keyboard or the piano or something.
Yeah.
So
well, we are limited to what a piano can play, considering we're working with MIDI inputs. So MIDI inputs are usually mapped to every note in a piano or every note in a standard instrument. But you're not limited to notes. The way our UI is designed, if you try it on your end, you'll see that you're limited in terms of note duration. So you're limited to 16th notes. If you wanted something shorter than that, like you can't do that. But in terms of notes, you can do any kind of notes. You can do sharps, flats, which in Indian classical music is komal swar. You can put that in as well. So you can do all of those things. So if you wanted, technically, you could put in a raga in there. You'll just have to sit in and integrate, fill in those boxes and know what you're putting in. That's all. But you could put that in. I don't know how that would perform, but that's the beauty of it. It can be trained on any kind of MIDI information you give it. So as long as we're able to convert the audio input to MIDI is rather robust, like I mentioned before. And we didn't even have to work with audio data. It was just text data because MIDI encapsulates that audio information in text.
Yeah, so going ahead, Bridge, right now we have just trained it on the outputs that were available to us from the Google dataset. But going ahead, if it requires, then we can train it on Indian ragas and other stuffs as well. Because we are not limited by the piano, we can change the front end. And also, since we are working with the MIDI file, you can always take it to other instrument as well.